Good morning students. Welcome to video tutorial class. And today's topic is periodic table properties and variation of the periodic properties. In previous class I have detailedly discussed about what is periodic table, classification of the periodic table, and many scientists have put forward their statements regarding this periodic table. Now coming to the properties as well as variations. Variations is nothing but trend in the periodic table. There are usually 6 properties in the periodic table: atomic size, metallic character, non-metallic character, ionization potential, electron affinity and electronegativity. These are the 6 properties of the periodic table. Now let me study one by one properties of the periodic table, and we can see the trend how it is going to change down the road as well as across the period. Coming to atomic size. Before going to this, I will say what is the definition of atomic size. Atomic size is nothing but the distance between the center of nuclei to the outermost shell. To the outermost shell is called as atomic radius or atomic size. Atomic size is nothing but the distance from the center of the nucleus to the outermost shell is called as atomic size. See here, suppose you take this as a nucleus, it will be having number of shells. This is nucleus and this is outermost shell. The distance between center of the nucleus, to the outermost shell. This is called as atomic radius or atomic size. It can be denoted by small r. This is called as atomic size. Atomic size is nothing but the distance from the center of the nucleus. This is pure nucleus from to the outermost shell is called as atomic radius. Or another definition of atomic size is half the internuclear distance between two combining atoms is called as atomic size or atomic radius. Half the internuclear distance between two combining atoms is called as atomic size or atomic radius. See here, suppose you take this is one atom and you take this is one atom. This atom has a nucleus here and this is another atom which has a nucleus here. Half the internuclear distance, see, this is called as atomic radius. This is the definition of atomic radius. On what factors this atomic radius or size depends on? It depends based on only 2 factors, that is the number of shell as well as nuclear charge. It depends on number of shell as well as nuclear charge. Causes for atomic size. One is number of shells, and another factor is the nuclear charge. Number of shells. As we go down the group, number of shells increases. Number of shells goes on increasing. As we go down the group, number of shells goes on increasing. Because atomic size goes on increasing down the group, so only number of shells increases. Suppose, for example, you take hydrogen, helium, sodium, potassium, rubidium, cesium, francium. Here, down the group, the number of shells goes on increasing. Suppose you take hydrogen like this, lithium like this, sodium like this, potassium like this. But in case of potassium, number of electrons in the outermost shell increases compared to that of sodium, but shell remains same. This is down the group, the number of shell goes on increasing in case of atomic size. Across the period, the number of shell remains same, but the number of electrons will accommodate to outermost shell. Due to increase in the number of shell, there will be decrease in the nuclear charge. Due to increase in the number of shells down the group, there will be decrease in the nuclear charge. Because the distance between the nucleus and the outermost shell goes on increasing. These leads to decrease in the nuclear atomic size. Trend in the atomic size. One is number of shells as well as nuclear charge. If number of shell goes on increasing due to increasing the atomic number, thereby nuclear charge decreases. Nuclear charge decreases. Why this nuclear charge decreases? Because there will be less force of attraction between your nucleus as well as outermost valence electron shell. Outermost valence electron shell. So only your nuclear charge down the group goes on decreasing because number of shell increases. This is about the trending causes for the atomic size. Causes for the atomic size. Now let me discuss about how is the trend of this atomic size down the group as well as across the period. Down the group as well as across the period. First, down the group. Down the group. Down the group. See, listen here. Down the group, you take lithium, sodium, potassium, rubidium, cesium, francium. These are the group first element which are also called as alkali metals. Down the group, what happens to the atomic size? Down the group, atomic size goes on increasing. Down the group, atomic size goes on increasing. This is because the number of shells down the group will be increasing. Example, down the group, atomic size, down the group increases. Down the group, the atomic size increases. Example, suppose you take hydrogen. Hydrogen, it will be having only one. This is a nucleus. It will be having only one electron. Next, down the group, lithium. It has 3 electrons like this. This is the nucleus and it will be having 1 electron, 2 electron and 1 valence electron in the outermost shell like this. This is your nucleus, 1 electron in first shell and 2 electrons in first shell and in second shell only 1 valence electron is there. See here, compared to this, the size of this shell in case of lithium increases with the atomic size. Means down the group always the atomic size increases because number of shells goes on increasing. Again, another example will be that is sodium. Sodium. It has 11 electrons. That is 2, 8, 1. 2, 8, 1. 1 electron will be in outermost shell. 1 electron it will be in the outermost shell. See here, this is your nucleus part. 1 shell, second shell, and this is third shell. And this is third shell. See here, in this you will be finding 2 electrons, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8 and 1 valence electron in the outermost shell. 1 valence electron in valence shell. See here, atomic size down the group increases. Atomic size down the group increases because the number of shell down the group increases. Because the number of shell down the group increases. What happens to nuclear charge? Nuclear charge down the group goes on decreasing because the number of shell will be increasing. Due to this number of shell increases, the force of attraction between the nucleus as well as the outermost shell will decrease, and this nucleus does not hold this electron tightly, so only the nuclear charge down the group goes on decreasing. This is about down the group how the atomic size behaves. What happens to across the period? Across the period, that is nothing but across the period the atomic size decreases. The atomic size decreases. Example. Across the period. Across the period. What happens across the period for this atomic size? Atomic size across the period decreases. Across the period it decreases. Across the period it decreases. Again, example, you take sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Sulfur, chlorine, argon. Atomic size across the period decreases. Suppose you take sodium, which will be having 11 electrons, it will be having 12 electrons, it will be having 13 electrons, it will be having 14 electrons. In case of sodium, it will be like this. In case of sodium, this is the nucleus, and here it will be having 2 electrons, and here it will be having 8 electrons, and here it will be having only 1 electron. In case of magnesium, again 1 electron will be added. Again 1 electron will be added to this chain shell. In case of aluminium, 3 electrons will be added. 3 electrons will be added. But in case of argon, it will be having octet configuration. That is nothing but 8 electrons in the outermost shell in order to gain the stability. The trend here across the period is nothing but atomic size across the period decreases until chlorine. Exception in the case of argon. This is because in the outermost shell, maximum accommodation of electrons, that is 8 electrons, will be accommodated. Hence, this element will gain stability. This is about across the period. The atomic size always decreases. Exception in case of noble gases or inert gases such as argon, etc. This is about atomic size across the period or along the period. That is nothing but from left to right. Left to right. This is about atomic size or atomic radius across the period. Now let me know how formation of cation takes place, anion takes place, and what do you mean by isoelectron species? See here, always the cation will be smaller compared to that of your sodium atom. Example, parent atom will be large compared to sodium ion. Example, you take Na, which will be having electrons 2, 8, 1. 1 electron will be in outermost shell. When it loses 1 electron, it forms sodium Na plus ion. It forms Na plus ion, which will be having electron 2, 8. That is outermost shell. It accommodates 8 electrons and attain maximum stability. This is how it forms cation. Coming to anion. Here, in order to form cation, always an electron should lose. In order to form an anion, always the electron should add. Suppose example for this anion is, to take example chlorine, Cl. It will be having 70 electron, 2, 8, 7. When it adds 1 electron, it undergoes Cl minus, and it will be having 2, 8, that is nothing but 8 electrons in its outermost shell. And this chlorine molecule will gain stability. Chlorine molecule or chlorine ion will gain stability with outermost 8 electrons. This is about cation anion. Here, parent atom will be larger in size compared to your sodium ion because already 1 electron has lost. But in case of anion, here chlorine ion, what it is there, it will be having larger size electrons. 10 electrons. This is about isoelectric